Hello, grade 6. Today we are working on Nelson Math, chapter 14, section 1, describing rotations. In a younger grade, you may have learned rotations as turns, but the proper name is in fact rotations. We're now able to more precisely measure the way that the rotations might work. You've already used some rotations. You might describe one full rotation, half a rotation, but we have many more ways to describe them, and we're going to do a few of those now. Right here you see our protractor. This protractor is the tool we use to measure angles. I'm going to point out that for the purposes of measuring angles, there are two different sets of numbers that we can use. If we start from this side, on the left side, we see that there's a 0 here, and that would be this angle right here. That would be a 0. So a 0 is a straight line. However, the numbers do increase on this side from 10 to 20 to 30 to 40 to 50. So as we start here in the left side and go around, the numbers are increasing. They go all the way to 170 and 180. So you can use that scale. But there is also a scale on the inside. You see here, it starts from here. It's 10, 20, 30, 40, all the way to 170 here. But 180 would just follow along onto this line here. It's not labeled because it doesn't have to be. Right here, this must be the 180. Just for the purposes of space, it's not labeled. As well, this 10 here is not the final degree measurement. There's also a 0 degrees here. It's just not labeled. This little white dot right here is where the vertex of the angle goes. So where the two lines meet that form the angle, that has to go in here. This particular protractor has a ruler on the inside and has a ruler on the outside. Different protractors will look different, however, they all perform the same function and they measure an angle. You can see here, now I've added the picture of an angle, and this angle is made up of these two lines that meet at this point right here. So to measure this angle, we want to know how much these two lines open up from this arm of the angle to this arm of the angle. However, there are very specific procedures that have to be used. So as the protractor and angles are right now, we cannot properly measure this angle. We have to move either the protractor or the angle to be able to measure this angle. The first thing we have to do is to get this particular vertex right there where these two lines meet. We have to get this little point into this white dot. So we can do that very easily by dragging right here. However, there is one more thing we have to do, and that would be to take one of these arms and put it on this solid line right here, because that's our 0. We always start off counting at 0, and in this situation, we are counting number of degrees. So I'm going to rotate that right now so that I have the pointy part where the lines meet will be in the white circle, and the one arm is going to be on this black line. So I've just moved my angle. So you see one arm is right here. The other arm appears to have disappeared, but it's actually right on this 0 degree line right here. So this 0 degree line where we're starting, as the angle opens up, this long side right here is pointing directly at the 30. That means that this angle is 30 degrees. We know it's 30 because we always start from the 0. So because this angle here is on the left side, we're going to start from the 0 on the left side and count up 10, 20, 30 degrees. The way that the angle is right now, we would not use the one starting from the right, which would be this one, 0, 10, 20, 30, 40. We would not use that one because we didn't start off the angle on that side. For us to use this scale that starts from the right, we'd have to move the angle all the way around. So of course, that's what I just did. I redrew the angle. I just moved it onto this side. And you see now this line, which is on the 0, this 180 does not apply because our angle here always starts off at the 0. So we're looking at the inner scale right here, starting off at 0. And like our previous one, this angle here goes from 10, 20, 30. And this angle, the same as it was on the other side, it's 30 degrees. Now we're continuing with some definitions. Here is a rotation. You can see that the word you used in the previous grade is still there. A turn of a shape described using the angle of rotation, the direction, and the center of rotation. You need those three things. So the angle we just did, you learned what the angle was. That would be how much you turn. The direction would be clockwise or counterclockwise, and the center of rotation would be the point that a shape rotates around. So that center of rotation does not move. Clockwise and counterclockwise are defined here at the bottom left. If you have an analog clock, not the digital ones that just say the numbers, but the ones with the second hand and the minute hand and the hour hand, the clockwise movement is always in this direction. It's always like that. Whereas counterclockwise is always against or opposite of the clockwise. So here I have a blue arrow that we are going to be rotating. So I have to choose these three things. I have to choose the angle of rotation, the direction, and the center. I'm going to be choosing a 90-degree rotation. The direction will be clockwise, and the center of rotation, I will choose the B. So right here, I've labeled my instructions. I'm going to make a 90-degree rotation, counterclockwise. I could have written out clockwise. I could have written out clockwise, but I just shortened it to CW, about the point B. Point B is right here. So if I'm rotating it about point B, it means point B is not going to move. Point B will stay right there. Everything else moves around it. If you're familiar with the pivot in basketball, the pivot foot is the foot that stays in one spot and your whole body moves around the pivot foot. So I've just rotated it. You can see now where everything is now pointing. So this is my initial one, the one that I started with, the blue arrow pointing upwards. But because I did a 90-degree clockwise, I rotated it this way in the same direction as a clock. So it rotated this way. And about point B, you can see the B is labeled here twice. You can see the B, this B applies to this blue arrow, and the B that's kind of hiding underneath here applies to this blue arrow. So these two blue arrows are exactly the same. They're just pointing in different direction. My A, which started off right here, is now down here. This is how we do a 90-degree clockwise around point B. I'm now going to show you how to do a rotation about point A. Here's my original blue arrow, the one pointing up, and I just rotated it. So now this is my image. I've rotated it 90 degrees counterclockwise. So instead of it going clockwise the way we did the first one, it's now going counterclockwise. So it's going this way. And I moved it about point A. So the A is the point that's not moving, which is still there. So that's how I was able to measure the movement of the rotations of the blue arrow. Thank you, everyone. Have a good day.